In this video, we're going to be taking a look at function notation where we're solving for an input. An output will be given. We're going to be solving for that input. So our function in this particular example is going to be g of x. G of x equals x plus 5, quantity squared. So the question might be, when does g of x equal 49? Basically saying, when is the function equal to 49? So what input or what number would I have to put into the function to get an output of 49? I do not know the number that I'm putting in. That's what I'm solving for. So in this case then, I want the function to equal 49, so I'll substitute basically for g of x. I want it to equal 49. I'll put that underneath, and it's equal to the function x plus 5 squared. Now in this case, I wanted then to take this, because I have an exponent of 2, I want to take the square root of both sides to get rid of this squared. Now, the issue that you need to understand is that when you have x squared situations, what does that equal to? Well, what's going to end up happening is you're going to have plus and minus 7 equals x plus 5. Now, where that comes from is think about this. If you have a exponential equation like x squared equals 4, right away off the top, most people will say, well, that's simple. The answer to that is 2, because 2 squared is 4. But there also is another number that if you square it makes 4. In that case, of course, would be negative 2. Negative 2 times negative 2 is 4 as well. So if you're going to solve an equation that has an x squared in it, which this one does, then you have to take the square root of both sides, and it yields 2 solutions. That's what this 2 is standing for, is that there are 2 solutions. So then x would equal positive and negative 2. So we're using this thinking right here as we go to solve over here. So when we take the square root of both sides, we actually have a positive and a negative 7 coming out of that square root because of our x squared in the equation. So now I need to then solve that, and I split that into 2 equations. So I have the plus and minus 7 equals x plus 5. So then I'll take the positive 7 version and put it over here. I'll take the negative 7 version and put it over here and solve for x. So in doing so, I would subtract 5 on both sides of each equation, solve it, and x equals 2 and x equals negative 12. These would then be the inputs into the function that would give us our outputs of 49. So if I were to put g of, in this case, 2, or g of negative 12. So in this function, I could put in g of 2 equals, and then I would substitute 2 back in. That would be 2 plus 5 squared. 2 plus 5 is 7. 7 squared is 49. And that's exactly what I wanted back here. Now it also is going to work for that negative 12, because remember, we had 2 solutions. So g of negative 12 is also going to work. So if I plug that in, I've got negative 12 plus 5, and that quantity squared, and that's negative 7 squared. Negative 7 squared is also 49. So the 2 solutions or inputs would be 2 and negative 12. And that would solve a question where you're given the output and you don't know the input.